Welcome to Architects for Change, the podcast that bridges the gap between architecture, the built environment, and politics. I'm Jay Morton, your host. I'm an architect and political geek, and together we'll hear from the change makers and thought leaders who are shaping the future of our cities and spaces. Our conversations will tackle pressing questions that hold the key to our future. How can we achieve a net zero future? What does it truly take to design a better world? And most importantly, how can politics play a pivotal role in breaking down the barriers that hinder progress? Okay, welcome, Steve, to the Architects for Change podcast.
Thank you very much.
I think you're actually the first engineer that I've interviewed. And obviously we know each other because my practice has worked with you on a number of projects such as, I think, Elephant Park Pavilion, to name a few. And I think working with you, you're definitely somebody who thinks outside the box, and you're definitely the sort of one of the people to go to if you want to test something a little bit new and a little bit more innovative, which I know we're also working with you on Brent Cross Energy Centre as well. So maybe let's start a little bit more, maybe about a short bit about you and your journey into engineering and how you've sort of evolved your focus into that sort of more innovative use of materials and sustainable approach.
I think I was reading your questions on the train over and trying to think what I was going to say. My grandmother had a haberdashery.
Right, okay.
And she was like this incredibly intelligent woman, very, very practical, cutting patterns for dresses and things like that. And both my grandfathers were mechanics. My other grandmother worked in a factory. My mum is a draftswoman, and my dad is a telephone engineer. So I think I have practical intelligence genes, perhaps. And I grew up in sort of between Bedford and the Middle East. So my dad went to live in Dubai in the 70s, which was sort of quite a different place to what it was now. And we lived not in Dubai, but in Fujairah, which is on the opposite coast in the mountains. And almost everyone you met was some kind of engineer because they were all building. So there would be someone building a dam up in the mountains. My dad was like connecting all these distant towns and deserts and the telephone system, and the guy next door ran the port, or somebody else was fixing the ships, and then you're just surrounded by people making things.
So this is quite like the early days where the kind of building was really signed up then.
I mean, it was they had the main street of Fujairah, they kind of colloquially called Oxford Street, and it was basically a line of shops selling storm lamps and shovels and pumps and Toyota Land Cruiser 4-wheel drives and kind of unpaved road. And so it's kind of quite, incredibly beautiful and interesting place, but also just surrounded by people who were building things and quite adventurous, intrepid people. So they'd all been working in Iran or Iraq or Hong Kong or, all around the world, full of stories, and just kind of surrounded by these people who are just, building things. So I think that's where I kind of first thought about becoming an engineer. I wanted to be an engineer. Also, I wanted to be an archaeologist. We did a play about Heinrich Schliemann, and I was thinking that it's all sort of related to shovels and digging. Like just kind of either putting it in the ground or taking it out of the ground. So I nearly changed actually from engineering to archaeology halfway through my degree, and I just hated studying engineering. It was incredibly dry, and I was kind of good. I was good at art and I was good at maths. Not that good at art and not that good at maths, but I did English lit a lot, so I'm kind of straddling, I think, slightly. So I think I'm a little bit in the wrong job, but I worked in the beginning as I worked in Guatemala for a while, putting concrete floors in people's houses. I was a site engineer, and then I was a tunneling engineer on the Jubilee line. So I was down the tunnels for alternate 12-hour night shifts and day shifts. So
so you did get some daylight?
Not often.
Wow.
I have to say. I mean, it was pretty kind of incredible environment down the tunnels, sort of Ridley Scott.
I can't even imagine what that must be like a day going to work and then you're just going underground.
Oh, you'd arrive. I mean, on a night shift, you'd leave at 7 in the morning and go to the pub in Bermondsey Market, quite probably have quite a few beers, and then go to sleep at lunchtime, and then everyone would turn up in the afternoon at 7 o'clock to start the night shift.
Wow.
Stinking of alcohol over, which was but it's just an incredible incredible experience. I mean, not a particularly pleasant one, but you know, lots of people with missing fingers and lots of swearing, and so it was kind of uh, quite interesting and an amazing, and again, a kind of practical education. You know what you can and can't do on a building site, and
So you're being like right up close to the materials that are being used, how it's being used, the kind of construction process.
yeah, just being around it every day and seeing what people are doing and how they're putting stuff together.
So have those experiences and that exposure, that what sort of then led you to, I mean, has that sort of informed the practice that you've set up in Webb Yates Engineers?
So I think I kind of, so we've been in the ground for, I think, 2 years. I was working on that thing and really just exhausted. I was probably the best paid engineering graduate, apart from all the ones that went to work in banks, but the most exhausted. But then we got to the above ground works, and Ian Ritchie was designing the kind of the shaft heads, and so suddenly, after spending a lot of time with people with missing fingers who only used one word, 4 letters beginning with C most of the time, suddenly to be confronted by Ian Ritchie's team, like quite high-tech, high-end architecture, was such an incredible transition that I thought I'd really like to kind of get out of that and move to a design office. So I went to work for Whitby Bird. So the Jubilee line was all high-tech, and at that time we would still be looking at the Lloyd's building or the Pompidou Centre, you know, thinking what an incredible... And when I was at Whitby Bird, they sent us to the Art of the Engineer exhibition in the Pompidou Centre, which is a huge exhibition of international, you know, all the famous international 20th century, 19th century engineers, incredible models. It's really inspirational experience, and a kind of and a display of the culture of engineering, which I think isn't readily available unless you really look for it. And I think
that is true, actually.
I don't think you know, engineers don't study history of engineering the way that architects.
And do engineers consider their work an art?
I mean, I do.
Yeah,
absolutely.
But do all engineers consider it?
I don't think all of them do. I think there's so I think because I'm sort of a slightly arty, slightly maths in the middle, then I'm really interested in the creative aspect of it. But I think this kind of false split between architecture and engineering really chooses people to self-select and drives them apart to a certain degree. So you have all the left-hand brain people choosing the colours of buildings and all the right-hand brain people doing the statics accountancy, and not many people rationally seeing the interconnection of those things, which I think is what really...
And it's like creative problem solving, isn't it? It's having the ability to solve the problem in a technical manner, but actually having that creative way of thinking to, I think what is the art of the possible, and thinking beyond the bog standard way of doing things, which we've already had a conversation about in the walking around of the studio, with some really exciting projects and in interesting materials and, you know, models on display, which again, you don't see that in all engineering firms either. So I suppose you're saying that having those two sides, that sort of has fed into the practice.
Yeah, I think somebody my partner's always asking me if I wouldn't rather be an artist, or people say, would you rather be an architect? And I'm like, I would really miss the maths.
Yeah.
You know, and I think if I was only doing maths, I would really miss kind of drawing and creative. But I think, you know, like I was kind of thinking, if you're a pianist, you have to do a lot of boring shit.
Yeah.
A lot of scales and a lot of boring learning before you get adept enough to improvise.
Yeah.
But once you get there, and I think if you understand materials and statics and structures and maths and stuff like that, and you get to a point where you have a kind of freedom of movement within those spheres, then it's an amazing creative medium.
So you need to have that full toolbox.
Yeah,
available.
It takes a really long time, and it's really boring getting there. But once you're there, you know, and you can just sort of draw things out and judge things and do the numbers, and I'm really, I'm concerned with things being rational and conceptually interesting, but also beautiful and kind of moral. And I think that's a kind of way of approaching an engineering problem rather than just
So this is then, I guess, for maybe when we start talking about materials, because there's a lot of work that you've been doing where you've been working with stone and you've been working with timber. I suppose it doesn't mean to say that you don't use steel and concrete as well, but there's always that consideration of how we can make this project more sustainable and like you say, maybe more moral. Maybe can you share maybe a specific project that you feel you've been most innovative and sort of expresses?
Well, I think we we have quite a big practice. We work in lots of different types of projects, and we work in all materials. And probably like every engineering practice, we're predominantly pouring concrete and making steel buildings. But we also find it really interesting to innovate with materials and try different things. So, and our kind of, I guess the trajectory of investigation crosses different projects. So we might have an idea on one project that gets an additional change or spin or something. So this is a long, boring story, but not long, boring story, but it's kind of, I was thinking, standing in Palm Springs.
Yeah.
And surrounded by rocks, seeing someone build a balloon frame timber house.
Okay.
And I remember when I was young, I was working as a site engineer in Guatemala with a lot of North Americans from Minnesota who were all kind of Swedish, sound like Fargo, the Swedish accented Americans. And they had this thing about timber and carpentry, and this sort of, you could feel this sort of slight sanctity of timber and carpentry work. And I was thinking, it's Protestants. That they're kind of, old Protestant settlers, working with wood, and that culture has extended
like
all
barn raising.
Or barn raising and all that stuff. It's just that culture has extended itself within the US so far south that they're building a timber balloon frame house in the middle of a desert full of rocks. And I started thinking about so in Europe you have, and I guess everyone in the world, the potato-tomato line. So everyone south of the potato-tomato line is eating tomatoes. Everyone north is eating potatoes. People in the south, hot countries, Catholics building in stone, and in the northern countries, Protestants building in timber. And this, talking to Carles Oliver, who's Mallorcan, Ibavi housing. So he was saying, there are 7,000 languages in the world. Why aren't there 7,000 architectural languages? We want to have a language that reflects our local environment. So they're building with stone. And I started thinking about what is for us in the UK. Yeah. What's our language going to be? Because we tend to reach for the CLT catalogue, but CLT is a northern.
When we say CLT, you mean cross-laminated timber?
Cross-laminated timber or solid mass timber.
Fat plywood.
Massive fat plywood. Not very efficient, and definitely coming from a place with a lot of forest, which is not us. So I'm thinking the stone isn't really us, and the timber isn't really us in that way, in the sort of solid timber way. We're not quite tomato, not quite potato. We're not quite hot. We're not quite cold. So we were doing buildings in timber, and then we do MEP and structures together. And discovering that if you do a timber building, you have to do a lot of air conditioning. If you do a concrete building, you probably don't have to have so much air conditioning, but you put lots of embodied carbon in the frame. So there's this dichotomy that people often talks about between lightweight and heavyweight building.
Well, yeah, because I suppose, so you're saying with the concrete, you have a thermal mass. Yeah. So if you heat it up, it holds its heat for a bit longer, so you can sort of temper it in a different way.
So you can open the windows at night. Let the frame avail itself of the cold, and then close it up in the daytime and keep the building cool on the inside without air conditioning. So we did Wimbledon College of Art, which is a timber frame building, and we did a whole series of studies to work out how much concrete we needed. So we have a timber building with very thin concrete slabs in the soffits of the spaces. So you have this really beautiful material combination of timber and thin, lightweight concrete, and quite structurally expressive, but it has exactly the right thermal mass not to have any air conditioning.
Right, okay.
So we did another building, the Anna Freud Center in Pentonville, which is the same, much bigger building, concrete and Albuquerque. And then we were thinking, well, the next evolution of this is to get rid of the concrete. And so we're working in stone quite a lot. So we want to do timber and stone hybrids.
So the stone is replacing the concrete for the thermal mass element. Yeah.
So we have small timber components, the kind of timber that you can get in the UK. So you can get Douglas fir, within 50 miles of London, you can get Douglas fir quite economically. And you can get small stone tiles, like paving slabs or York stone or Portland stone. So if you combine these two materials, you end up with this sort of not quite tomato, not quite potato vernacular that works for us. So we've done a back extension in North London where we have a long span reinforced stone beam, timber and stone composite floor, and you can see it in the ceiling, and it's just it's beautiful, it's natural, it's extremely low carbon, it works for our climate, and it works with the materials.
And these are materials that in theory should be readily available in the UK and to be made in the UK. So the wood is wood that we can grow, whereas like we were saying, cross-laminated timber, we don't make that here because the trees aren't the right kind of trees.
The trees aren't the right kind of trees. We don't have the volume of timber. I think we're joisty people, and
stick building.
Stick buildings, joists and slabs. So I was we've done a whole series of buildings and proposals developing this idea of timber and stone composite. So we're doing some robotic assembly of this as an experiment at the moment, and various other buildings. But it's just, I think, what excites me is that it's potentially, and I don't know whether it'll ever catch on, but it's potentially a really good vernacular. It gets around fire, gets around durability, gets around air conditioning, very low carbon.
And what kind of heights would we be talking about for this?
You can build any height with that.
So even a tall.
So you can build so in parallel with that, we've been experimenting with reinforcing stone. So putting cables in stone elements, post-tensioning them, so we can make really long span stone beams, have a fraction of the carbon.
Is this like what Pierre was talking about when I interviewed him, his kebabs?
Yes. Yeah, he calls them stone kebabs.
Stone kebabs. Yeah.
But those have the capacity to solve long span situations, and they're about the same depth as steel and about 1/10 of the carbon.
1/10 of the carbon, so that's big.
Yeah.
Do you feel that, why do you think maybe, how do I rephrase this question? Do you think that we're not innovative enough in the construction sector? Do you think we're a bit lazy? Do you think the sector as a whole is a bit lazy in trying to do things better?
I think there's a huge inertia. There's a fear of risk. I think particularly, I have a lot of sympathy for contractors. They have so many things to deal with, so many logistics, so many risks and imponderable situations that you can understand why they don't want to innovate.
They don't want to do it. This is how we did it last time.
Well,
we'll do it this way again.
The status quo probably doesn't always go very well, so why would they throw in extra? So, I kind of get why people want to stick to what they know. I also think there's a massive investment in infrastructure to deliver the normal stuff that we're building with. So I went to a steel plant in India, and you can just see they're getting coal deliveries from Australia. So somebody's digging up coal in Australia, sticking it on a train to the coast, putting it on a ship, taking it to Goa, shipping it hundreds of miles inland to this place. Coal is going through the gate, getting coked, goes up the chimney in the blast furnace, all of it, all the coal. You see these trains pouring through the gate. Every bit of that coal is going up the chimney as carbon dioxide to make steel. And steel comes out, rolled, processed, reprocessed, sent to the UK. All of those processes, the steel is cheaper when it arrives here than if I dig up some stones from a quarry in Cambridge and put a small cable through them and turn them into a post-tension stone beam. But clearly the stone beam is far more succinct than the route that the steel took. But the steel route is so industrialized and so developed and so that it's still more economical. So I think the sort of inertia of industrial development kind of keeps us on the track that we're...
And it's difficult to move away from it. I guess this is the thing, it shows actually the market is all wrong. That piece of steel, if it's damaging the planet in that way, should not be cheaper than the solution that's not damaging the planet. And we don't put a value on damage to the planet, I guess, in materials.
I mean, we do put a value on damage to the planet, but I think we miss... Well, they were talking about having carbon border tax, for example, which I think is going to do something to address, make a locally available low carbon material potentially a little more economical. But I think that carbon tax has to really bite. But as an example, I just bricks,
Yeah.
I mean, what a stupid material. just I mean, it's like from Victorian era, designed to be carried by some sick fish and chip eating Victorian bricklayer.
Yeah.
In today's era, it just seems crazy. We produce 240 billion bricks a year in the UK, and they're only decorative. Slow to build, and if you work out the carbon footprint of that, it's about half the output of a nuclear power station.
Yeah.
So it's like we would rather spend billions on nuclear power to decarbonize than just ban bricks.
Yeah, but then I suppose what's the alternative?
Well, there are lots of houses that are not made of bricks.
Yeah.
I went to Yerevan in Armenia recently, and it's full of tuff, which is volcanic ash stone. All the Soviet blocks are clad in this pink tuff. The whole place, just incredible, very beautiful. And there's black stone everywhere, and cities, half of the UK, the cities are stone. They're clad in stone or they're built in stone. It's only certain places that are bricks.
Yeah.
Grimshaw was doing light gauge steel cladding in the 80s in Camden, and that place. I mean, there are lots and lots of examples of other kinds of
We need to move away from, I suppose, that sort of default planning, like brick is the way everyone likes brick. That's the sort of, what the building should look like. I mean, we use brick all the time, and I think part of that is, like you say, it's low risk. Builders they know how to do it. They know the supply chain. I mean, I think it is quite mad that even hand laid brick is still quite economical in the sort of market system that we're working with for like a tall building, which makes absolutely it blows my mind that is still more economical than maybe a more a sort of factory built system as well, which we're still building in such a historic way.
I don't know. I mean, I don't really like rendered buildings, but most buildings in Germany are just rendered, and like that's much more economical and much more environmentally friendly.
We actually did a piece of research of all the different, and actually the render came out the best in terms of carbon. So maybe that is the challenge. How do we do? Because also I suppose you can make the building lighter, less foundations, less weight. How do we do it? Can we do it with good rendered building that lasts?
We're doing a 16-story housing tower, and I said to the developer, look, we should just clad this in brick slips. Oh no, I don't want brick slips. I want proper brickwork.
Yeah.
There is nothing proper about brickwork. You're just putting 100 millimeters of decoration on instead of 30 millimeters.
Yeah.
It's not structural. It's held together by bits of stainless steel and pins and shelf angles. It was 900 tons of brickwork on this building. And
like you say, there's tons of aluminium or steel,
and all the stuff that goes together. It just seems completely ludicrous to be doing that. But we're kind of, and I think, as you say, planners like it. Architects know that they'll get an easy ride with the planners and the contractors by choosing brick. The contractors know the bricklayers and the brick suppliers and the brick factors, and everyone is kind of locked to this dance of continually repeating this thing.
Yeah.
And meanwhile, the government's going off and building nuclear power stations to decarbonize,
Yeah.
It's like, I think it's sort of, the boat is leaking. Do we plug the leak or do we buy a bigger pump?
Well, yeah.
I think like stopping the use of carbon at source rather than investing in.
That's the thing, isn't it? We all need to kind of stop. I mean, I've been saying this a while about innovation in construction, and obviously the government want to build 1.5 million homes. It's like, okay, that's great. How are we going to build them? And people will keep saying, oh, they'll be sustainable because they have solar panels on the roof.
Yeah.
And you think, well, actually, it's much more than that, because like we said, we've got this 38% embodied carbon.
The embodied. So I guess the carbon targets are not really tackling embodied carbon very effectively. The building boom, if it's built in concrete and brick, is going to have a huge carbon footprint, and will be a massive, I think, a climatic disaster if we build all of those houses in the way that we've habitually been building them. And I don't think there's anyone waking up and recognizing it as an issue.
And I suppose there's an opportunity for other industries that we could create. So like you're saying with stone and with timber, that we can actually invest in making things here, and it could actually be quite good for the economy.
Yeah, I think, well, there's another kind of chain of thought that I heard, the Luddites, neo-Luddites. So the Luddites obviously were weavers working on their own in little sort of Silas Marner, working in little cottages in the woods and weaving. And the first power loom came along and they went in and smashed the machines because they didn't want their livelihoods destroyed or their way of life destroyed. And obviously economists would say, that actually those people were released for more productive labor elsewhere. So I guess at the beginning of the Industrial Revolution, a lot of people living in poverty and quite a small global population, you could release all those people and they could do more productive things and produce more stuff, and we all get more stuff. And that, I guess, in a background of poverty, you know, increase in productivity makes sense. But in a society that really overconsumes, you know, swamps of pink Barbies and plastic toys and whatever stupid kitchen gadgets you get to do things that you could perfectly well do yourself in the first place. And, you know, in a society that really overconsumes at great environmental detriment, do we want to release people to greater productivity?
Yeah.
So, or would it actually be better to employ people doing things more laboriously in jobs that are satisfying and that they enjoy, can potentially decarbonize? So we're looking at... I
was going to say, this leads quite well to your Craft Not Carbon project.
Yeah.
Yeah.
Well, I mean, before getting onto the Craft Not... after the Second World War, there's a huge shortage of coal and there's a sort of excess of labour. And so all of these, Eladio d'Este, Felix Candela making really thin shells, Eladio d'Este making those incredible market shells, Nervi in Italy, Campo dello Sport. You know, it's expedient to spend money on people, carpenters making inform work, engineers, designers, really slimming down the volume of concrete. You know, it becomes feasible that you can employ people to do a lot of work to decarbonize. And I think the fact that you put income tax on people making labor more expensive, but you don't put it on material, means that labor is more expensive. So we will build lazy flat slab structures that actually increase the volume of material in order to displace labor. Whereas if you move the tax from the person onto the carbon, suddenly they'll be saying, look, I'll double your fee, I'll get in all the carpenters you want, but we really have to save some concrete on this.
And some good thinking time. Because I suppose this is the other thing with, and without criticizing engineers too much, but I guess there is this also thing, it's the risk and the risk and the risk. So your concrete beam is bigger than it needs to be and then bigger again to sort of avoid the risk, rather than actually thinking hard of like what's the smallest we can make this.
Yeah, well, I think I definitely shouldn't say this on a podcast, but not enough buildings. I mean, buildings are too low risk.
Yeah.
Somebody said, really interestingly, there's enough, what was it, that there's enough air in the building for 2,000 people. There's enough structural capacity for 20,000 people.
Yeah.
So it's like, you know, you really over-design buildings, you make them way too safe, and you cut. That's not you. I mean, fees are cut to save time on design.
Yeah.
So things tend to get rationalized. And then there are factors of safety that protect against doing things too quickly.
But we can probably at least deal with the fee bit. That if an engineer is given a little bit more time, they might be able to sort of reduce the amount of material.
Yeah.
And I guess the same with
imagine
architects.
if you move the 30% tax from the designer to the material source, then suddenly they're going to be saying, spend 30% more time designing this and really hone down the volume of concrete. And that would and I think that would, you know, that comes out into site labor, so you could have a construction environment that creates highly skilled employment. People are better rewarded for doing a better job, thinking more carefully, working more carefully, and actually stop the coal pouring in through the factory gate and minimize the use of materials, would be better for everybody. And
it's actually a really good idea. No one said that so far.
Well,
as a concept.
Yeah, I mean, I think it's just the William Pitt the Younger introduced income tax to fund the coalition wars against Napoleon, or the First Coalition War, and he introduced income tax just after the window tax, just to put it in the context of how sophisticated their fiscal policy development was at the time. And the income tax is stuck, and it's ubiquitous, international. You know, tax labor, take power away from labor, put power in the hands of machines. Bill Gates is saying we should tax robots, you know, and more automation. Nobody's taxing machines. Machines get their food and drink free, you know, or, you know, tax free, whereas we pay VAT, or you know, so all of the kind of tax burden is on the person rather than on the material.
Got taxing AI as well.
Yes.
A whole other thing, which has actually already made a certain number of people unemployed. If you're a copywriter, you're not needed anymore.
Well, AI is gonna, I think, for every employee, for every worker that AI displaces, it also displaces a consumer.
Yeah.
So I don't know. I mean, it's just going to result in universal income, probably not very universal.
Yeah. Yeah.
I mean, what is the end game of that? And suddenly you have 8 billion people on the planet who you don't need to work anymore. As you think of humans as labor source, actually you don't need all those people. So what do? You can have a universal income in exchange for your sterilization. I mean, where is it going to go?
And then maybe we go back to craft and art and taking a bit more time on things, respecting things. I mean, that's the sort of nicer version.
Yeah, well, I think it's a slightly capital versus labor argument that the system at the moment is set in favor of machinery. It's set in favor of the person who built the blast furnace or owns a robot or has the means of automated production, at the exclusion of labor. Whereas you could just flip the tax onto material consumption, and suddenly better employment, better quality employment, and less environmental.
And I suppose this, maybe going back to the Craft Not Carbon project, it's that sort of thinking outside of the box of not following that sort of typical industrialized system, but it's actually, I think you as an engineer is quite good at sort of thinking of other ways of doing things. And so maybe actually if you give me a little rundown of that project, because I think that's really, really interesting.
So we were working with Studio SAR for a project in Udaipur in India, and we were building a sunshade on top of this. So it's a center for families and education, and people come with their kids and they do lessons and other events on this thing, and they had this big sunshading thing, and we got it on the back of the Dubai Expo sunshading. So we designed like quite big sunshading umbrellas for that project. And initially the idea was to make it with aluminium, and I don't like using. I don't mind using any material particularly, but like aluminium seems like an ugly solution because it's so carbon intensive.
Yeah.
And I really regretted that we weren't able to make the Dubai sunshades out of timber, and everyone's saying, "Oh, timber rots, and it's never going to survive this environment." Funnily enough, a really hot, dry environment is quite good for timber. And I can see things in Dubai that I remember from when I was a kid, like wooden umbrellas by the creek that are still there. So I don't even think that's true. But the Ananya Singhal, the architect, was saying, "Oh, timber's not going to survive in this environment. It's going to be falling to pieces after 5 minutes." And then we were looking at the guy weaving baskets by the side of the road, thinking, actually, how much does that guy earn? And they say they're getting about £2,000 a year or something, the guy's wages. And we're going to spend £200,000 of aluminium panels. Maybe we can weave panels, and maybe they'll last 2 years.
Yeah.
And we can just permanently employ that guy fixing, replacing, or him and his family in the school with the kids, with the people, a craft that everybody can witness, just permanently maintaining these things. It's actually far cheaper than, so I think people say, I want something durable like concrete.
Yeah. And
then you have the Hammersmith viaduct falling to pieces long before it's supposed to fall to pieces after like 60 years. And Thaden Boys is a 1,000-year-old timber church. And the reason the church is still there, they love it, they maintain it.
Yeah. And, so it's about that care and respect for material. And I guess also there's that other thing that if it's crafted, and actually this is, I mentioned with Keir Reagan Alexander, when we talked about AI, he talked about a cup that he cherishes it more than any other cup because it's been made by someone. You can see the thumbprint. So it is that, I think it's that respect for something that's been created by a person, and you can see it and you can touch it, which I guess is also why there's an element of sort of historic buildings as well, and they've got an element of craft. It's that, I guess, relationship to our history and ancestry, which I guess is partly what makes us human in a way. And I mean, how many years could you employ this guy for to keep, or employ his ancestors for?
I mean, I guess this building has 100-year design life. Something like that, and they'll just have to keep maintaining those things all the way through.
So £200,000, which is the equivalent cost of the aluminium, to employ someone for 100 years.
Well, so if I put £200,000 in the bank,
and
I get a 5% return, I get £10,000 a year. So I can have 5 weavers all the time, but I probably only need one weaver, so I can have one weaver. And I suppose in India, wages are going to rise over time, and the weaver will get more expensive. But I still think over the 100-year lifetime, if you invest the £200,000 now and you bank the return, you can probably still employ that person and create a life for somebody in the building amongst the kids, doing a craft with a natural low carbon material. And that you can see that there'll be different colored panels. I just and I think that the avoidance of maintenance often is worse than just embracing maintenance. And that what was it? There was what's his name? Stahl, the economist, was talking about the ability of labor to displace carbon, and really talking about repairing things. And rather than just throwing them.
Which we need to be doing with objects. The stuff in our homes, and starting to fix things. Again, I think it's about the respecting the... I'm actually even say it to my son with toys. I've started to say, you're the custodian of the... I think it sounds like sort of a knobby thing to say, but I'm like, you're the custodian of the object. If you don't treat it nicely, then we can't pass it on to somebody else when you don't want it anymore. And I do get really annoyed if things get broken, because you think, well, that's just going to go in the bin now. Whereas I can't then give it to another child or sell it on eBay or give it to charity. So I guess that's that sort of, I suppose, again, it's that different way of thinking, less throwaway culture.
I guess also it's what is it? So I mean, it's like a plastic. How are you going to repair a plastic toy? You don't have an injection molding plant in your kitchen.
No, exactly.
If the toy was wooden, you could conceivably saw up another piece of wood and sand it down and glue it together or something. And so I think there's also... We were thinking this slightly with the stone, and the fact that things are plastic means that only people with the means of production and large factories have the ability to produce those things. So it takes a sort of democratized means of production away from most people and puts it in the hands of particular people. And that the stone beam thing was a similar thing, that we were talking to Zimbabwean engineers, and they were talking about the balance of payments in Zimbabwe. They have a big economic problem, can't afford to import steel. And it's like, but you've got stone everywhere. If you build a stone, then you don't need to import steel. That's what you need to import bit to make the stone work. But there's kind of democratization of the means of production of construction. Everyone depends on, internationally, everyone depends on having a cement plant to build concrete frames, having a steel plant, which means that all the money goes to a certain group of people. Whereas actually I can put a circular saw, a bit of cable and a hydraulic jack in a suitcase. I can go to a quarry and I can make a stone beam given enough time.
Wow.
I mean, it wouldn't be a very good stone beam in my case, but a stonemason could. And I think that kind of, it localizes and democratizes the access.
It's also like the resilience of labour as well, because I'm thinking we're talking about steel plants, and actually the change, the Tata steel plant in Wales, that sort of reducing, or that closing down. I mean, it's not closing down now, but it's going into an electric plant, so it needs less labour, I'm correct. But that can actually completely destroy a whole town. If that was to close, that could completely destroy a whole town. Whereas, like you say, if you've got sort of, it's more almost like the small boats solution. But how do we try and sort of move away from the standard way of doing things? And what are the sort of biggest challenges, do you think?
I mean, I don't know how do you, I mean, we talk about these things and advocate for these things, and actually, I mean, particularly the stone things, I was presenting our work in stone, and mainly, so we've done quite a few buildings and real structures and stairs and different things, but a lot of the work, a lot of the things that we're experimenting with, we don't have any R&D budget, but people ask us to exhibit in museums, or we have opportunity. And if we can say to a contractor, we're going to get some PR if we do this thing, then they're happy to. So stonemason, we often work with a stonemasonry company who get the benefit of the PR of building something in a museum, or so we did the Royal Academy summer exhibition, or the V&A, or so we have these opportunities to experiment. But there's not really any real push from any big institutions to get behind this, and it's difficult for us to I think to persuade anybody to do it. But
So when you say big institutions, like contractors or universities, what's
I guess the government.
Well, the government, yeah, of course,
So
yeah.
you think let's build a huge nuclear power station.
Yeah.
The technical problems, the risk,
yeah,
getting into bed with foreign governments to build them that you then become suspicious of later on, or the endeavor of making nuclear power versus the endeavor of, say, building a stone beam plant or a CLT plant or a composite timber and stone plant or something, just putting, for a tiny amount of money, we could make these facilities that would develop, test, sell, and market those products, and just change construction. I mean, the cost of a nuclear power station, you could be free issuing CLT.
Yeah.
In tons. I mean, you could just give everybody free CLT for years, probably, to build everything. Compared to
to build the 1.5 million. You could actually let people build their own 1.5 million homes as self-builders with CLT and with a saw.
How many is 1.5 million?
It's 1.5 million homes in a term, so I guess that's in 5 years, I would assume.
Well, 1.5 million homes, if there are 100, so it's 1.5 billion square meters of 100 square meters per home, 1.5 billion square meters.
Yeah.
1.5 billion at £200 a square meter, so that's three.
This is the math showing.
It's 300 billion pounds.
Yeah.
Is enough to build all of the 1.5 million homes
out of cross-laminated timber.
And
then, but they don't have to be all cross-laminated timber. They could be stick, as we were saying.
Or joists.
Joists. You more of a stick.
Yeah, let's give out free
joists. Timber.
Yeah, so maybe that's half price, 150 billion.
Yeah, because obviously the CLT has to come from Europe.
Yeah.
So that's a challenge.
Yeah, so we could build some forests.
So we could all barn raise.
Well, I mean, if the government's going to spend all that money on nuclear power, is that a similar budget to give everyone free CLT or discount CLT or discount timber or joists or cutting the
to build a sort of timber revolution? Why you include stone into the mix as well? Because some of our 1.5 million homes will be tall, not all of them are going to be small.
Yeah.
So when you chuck stone into the mix,
the amount of investment required to make a stone beam factory on the side of a quarry.
Yeah.
I mean, you're talking £1 million.
So is this what you would say if you had Ed Miliband in front of you right now?
Yeah, so just put a bit of money, build a factory, start making decarbonized construction products. I mean, and actually create local work in the UK, new technology that could potentially be exported. It's a massive opportunity.
Yeah.
I don't know. Well, so when we talk about reverting to stone as a way of saving carbon, everyone is imagining cathedrals and castles and things. But actually, Victorian infrastructure, buildings, bridges, tunnels, lots of it stone.
And a lot of workers' cottages. Not just the mansions,
the houses, and workers' cottages, but also we built in the Royal Academy Summer Exhibition a stone space frame structure. So if you imagine the Eden Centre being a sort of space frame, little sticks connected together by nodes, we're building stone versions of that. So actually, you can really do quite technological things with stone, not in the way that you imagine. You can build stone trusses and stone frames and. So there are lots of avenues, not just big lumps of stone.
So the two materials that you think we should be pushing in the UK is stone and timber, and that's the sort of vernacular that we need to be moving towards.
Yeah, I don't think we will ever get away from needing steel, and I don't think we'll ever get away from needing concrete. I just don't think that they need to be the ubiquitous answer to pretty workaday.
We don't need them
problems, and I think a lot of people are saying, "Oh, is your house built out of traditional construction?" And it's made of timber. It's like most of London is timber. All the old Victorian buildings.
The facade was brick, but it was just brick. It was actually a structural material. Yeah. Which I suppose that's with like the 15 Clerkenwell Close, who actually the facade is the structure. Yes. If I'm correct. Maybe you could elaborate a little bit.
Yeah, I mean, I think it's a totally different topic, but we want we want the structure to protagonize in the architecture. I don't really want to design steel frames that people are covering in plasterboards. It seems really boring. And and it seems intellectually inelegant to design a structure and then cover it in a decoration. I think that is, and not that I'm opposed to decoration or things being elaborate. It's not an Adolf Lowe's kind of argument, but I just think if you solve the structural problem elegantly, it'll be something that you want to see. And I know that when we built Clerkenwell Close, obviously there was a bit of controversy with planning, and people were a little opposed to it when the scaffolding came down. Oh, they've built it out of recycled concrete, quite grey
Which
limestone.
shows how far removed from stone, which is a natural material, we've become.
Yeah. Oh, they said that's completely out of context. That is opposite the Hawksmoor limestone church. So I don't know.
It's just the stone as it is,
surrounded by 80s brick. Brookside Close, fake Victorian buildings, but I think when we were talking to them, saying actually the stone holds the building up, it's oh that's quite interesting. It's the stone that supports, and when I think that as well as its structural purpose, it gives it some depth, and it gives the facade some content that it doesn't have if it's just a decoration. So,
was it meant to be a little bit antagonistic?
Or
it was sort of an accident, but actually kind of works quite well to prove a point as well?
The finish on the stone is not at all contrived. It came from reducing the cost. So the stones were made with the absolute minimum amount of manufacturing. So they're plugged and feather wedged and split, and occasionally sawn. So you end up with the sort of 3 different finishes. But we really wanted to do the minimum amount of processing, mainly to make it economical. So it's something, it's a vernacular. It's
raw in a good way.
It's raw and it's vernacular, and I think really beautiful.
Do you think people? I'm getting the sense people are falling in love with it. Do you?
I know. I think,
now people understand.
Yeah, we're looking at. We're doing other buildings with Amin that are similar, but also we're getting lots of inquiries, and we're looking at a building with Big in Denmark for very similar kind of stone, much bigger stone frame, and so I think people, and I know it's our building, but I think it's one of the most interesting pieces of architecture. I feel like architecture is at quite a low ebb at the moment. Somebody interviewed me the other day about high tech because I was only just about there. And I was thinking high tech was an era where I think architects and engineers were interested in each other, and that they were, and the structure and engineering and architecture was sort of symbiotic, and that's, on the Jubilee line, and when I worked at Whitby Bird, and I worked for Calatrava in Spain, those were the sorts of buildings that we were building. And I think, we've lost that. Architecture doesn't have, I think sustainability and embodied carbon is an amazing opportunity. It's an amazing lever to propel architecture into a more interesting phase. Building concrete frames clad in brickwork looks like 1975. It's just not... And particularly when they're kind of faked up to look like Brooklyn warehouses with, and this, I think there's very little, whereas Clerkenwell Close is quite a, it's a kind of different kind of high tech. It's structurally expressive. It's materially interesting. It's addressing and asking questions about sustainability and materiality, and in a way that so many buildings that are basically boring concrete frames decorated in plasterboard and brickwork.
So this goes back to where you spend the money. Spend the money on the thinking time. And then we can actually come up with economical solutions that are problems, and collectively, engineers and architects working together, we can collectively push the boundaries. Buildings don't necessarily have to be more expensive if they're utilising different materials, but we need that thinking time, because again, it's back to the market and the economy of, well, we just need to do it this way because that's how the contractor wants it, that's how the planners want it, and we know how much that's going to cost, rather than maybe let's have a slightly longer design programme where we can actually start to utilise our brains and think about something slightly different. But I think there is, I don't know how you feel, but I think architecture and design and engineering as part of that, there doesn't seem to be so much respecting or understanding of what we actually do and what we can do.
Yeah. Well, I think maybe people have lost confidence in their ability to solve technical problems. I think the fragmentation of architecture was this, your conversation with Patrick Schumacher was talking about the fragmentation of architecture as a profession from, I guess there's, the history of engineers and I think engineers are kind of military, and architects come from stonemasonry. But I think over time, the technological power and ability of architecture, and to, I guess, maybe to a slightly lesser extent, but engineers as well, that they're kind of losing confidence in solving problems from first principles and having to rely on assembled systems, and therefore being limited to the systems that are available rather than being able to kind of reinvent the thing from the ground up. I think that's that's probably the cause of a lot of kind of sort of boringness in most building
mediocrity
and mediocrity. And but I think we need to upskill. And the people keep saying, well, we Clark are more close. Everybody says, oh, but can't be. How do you solve the thermal bridging? Well, I stuck a bit of insulation between steel connections.
I thought about it.
Well, it's like, well, oh yeah, but can you do that? So of course you can do that. And we used to. I mean, there's a kind of ridiculous example. When I was younger, when we were making concrete frames, if we had to make a thermal break, we would just stick a bit of insulation in the concrete and kind of cross tie it with stainless steel bars, and we would design it ourselves. Now, if you want a thermal break in concrete, you buy Halfen Shock, which is a German product imported from Germany, which basically does exactly the same thing as we used to do with a bit of insulation. It's manufactured somewhere. And now, if I say to someone in my office, we need a thermal break, it will occur to none of them to do anything other than buy a Halfen Shock.
I'm guilty of that too.
Well, you just, I mean, and then
because everyone wants the product that you can specify, and again, that goes back to risk again.
Well, then
we know it works.
So I said, we're just going to stick the polystyrene in the slab, and then someone's going to say to me, "Oh yeah, but who's going to warranty that?
Yeah,
are you going to warranty that?" And it's like, well, yeah, I will, because like I know it's going to work. I've done it before. I understand the technical aspects of it, and I'm designing it with. But the minute anyone says, "What about the warranty?" It's like somebody pulls a gun in the meeting, and everyone just backs away from the table. And I mean, I think I have to say, structural engineers carry a huge amount of responsibility for designs. So we are kind of designing from first principles, from the ground through the foundations, the frame, and we take full responsibility for that. There's no warranty on the structural design. And so I think for us, we're ever probably a little less afraid of taking responsibility.
Maybe than us architects are.
Well, I think in other sectors where people are just specifying systems, suddenly everything is a product from a catalogue with a warranty. I mean, the warranties are probably useless anyway. How many times do you successfully action the warranty?
Well, this is also true.
Everyone's going to come along and say,
you
didn't install it properly. Or,
you left it outside for too long.
We said in the back of our catalogue that we weren't actually taking responsibility for your. So I think we just need to be a bit more intelligent, a bit braver, and
it's true. And I wrote an article a few years ago, actually after COP26, like we need to legislate and innovate, and actually we need warranty providers, we need architects, we need manufacturers, we need everyone to kind of come together and be like, okay, what are the new systems that we can create? What is the new way? It's not even a new way of building. It's kind of the old way of building. But how do we solve this issue? How do we make doing things better and differently actually mainstream? Because I think this is the other thing. The construction industry is really, really slow to adapt. It's, cross-laminated timber. It still feels like this revolutionary new product, which has obviously been on the market for decades, but still trying to get that through because of cost, because of logistics, because of contractors not necessarily knowing how to do it. It always gets priced more expensive than the concrete frame solution.
I mean, I think the as you say, the construction industry is incredibly slow to change, and even the world's most futuristic project, I guess, the kind of neon thing, it's going to be a huge concrete frame structure covered in glass. And you think not only is that, what is the I was playing my kids Blade Runner.
Yeah.
The opening scene of, I forget the guy, who was the set designer, Stanley something or other. But
Stanley Kubrick, isn't it?
well,
No,
it's Ridley Scott is the director, but
Sorry.
Stanley or Sydney someone or other was the set
Yeah.
sort of architect behind the appearance of. So the opening scene is this huge, evil-looking city with gas flares and giant pyramids and flying cars, and it says Los Angeles 2019. Thinking that in 2000 or 1982, when they made that film, the person making that film would have grown up on a horse cart and seen people land on the moon.
Yeah.
And probably extrapolated that technological development to think that in 2019 we would be in flying cars in this incredible future. But actually our development has been much slower. And neon, the visuals of neon, flying cars, impossibly cantilevered buildings, they look very much like the sort of Blade Runner.
What someone thinks the future is, rather than what actually the future should be.
An arcane future. Do you see what I mean? I mean, it's an archaic future to imagine, like, have the same vision as somebody from 1982 for a city today.
Yeah.
And neon is going to be built with concrete and glass, which is kind of Mies van der Rohe 1930.
I got really freaked out about it, but I'm like, is this actually all the preppers are just going to, like, it's almost like their bunker? Yeah. And then we're all buggers, all screwed, and they're just going to sort of hunker down in this glass flying car, spaceship in the middle of the desert.
Oh yeah.
And so they don't care how much carbon they're wasting. I mean, that was quite a dark way of me thinking, but it does feel like that. So maybe sort of wrapping up a little bit on that dark point. So what actually gives you hope for the future? Are you optimistic, and how are you optimistic that we can drive change?
We had there was an engineering club talk or panel discussion called the thing "Are All Futures Dystopian?" And I was really disappointed to arrive on the not dystopian team, the dystopian team. But I was teamed up with a young architect of South Asian origin, and I was saying, oh god, the future's really miserable, and she was saying, actually, child poverty has gone from 80% to 12%, literacy has gone from 20% to 95%, infant mortality has dropped through the floor, and actually carbon emissions are probably peaking. The population of the world is about to peak. Actually, there's far more security and decency and human rights in the world than there ever has been in the period before. And when I thought about it, it's like, actually, we're kind of testing the world against what we think it should be. Clearly, it's full of problems, but actually, and I think it's I think that's all very. I mean, I kind of, but the other problem is that. So this is another long tangent. Agrarianism apparently was a trap.
Right.
So hunter-gatherers lived freely and didn't work very hard and just wandered around having sex and eating meat and fruit and whatever and lived quite well.
Yeah.
The minute they got farms, their population expanded, and then they got a kind of feudal system going, and then people were basically enslaved to the land, and there was no way back to hunter-gathering, although their lives as agrarian peasants was probably much worse than it was as a hunter-gatherer. And oil, fossil fuel, is a similar trap, that we've used fossil fuels to propel the population of the world from 1 billion to 8 billion people or whatever it is. There's absolutely no way back. And all of that development that she was talking about in terms of infant mortality falling and literacy and all the developments in the world really attached to fossil fuels. And the huge amount of energy that we're able to avail ourselves of. And I don't think there'll be any easy way. There's no easy way back from that. And so I do, ultimately fossil fuels are going to run out. And that we have to find a way of sustaining 8 billion people on a far lower energy basis than we currently do. And I don't think, so I imagine everyone's doing craft, not eating very much, not driving and consuming very much, kind of living a sort of more technologically advanced peasant existence, where you know, we might not be flying around the world so much, but just telling more jokes and
Yeah,
kind of
yeah.
having more quality time with our families, and you know, getting
And I suppose and being more creative and yeah, I suppose that's the thing. It's like the slowing down the process and like you said, democratizing what we're doing, and
yeah.
we're sort of more directly related to the construction of the buildings that are going on around us. But how? I mean, I suppose yeah. How do we think we get there? I mean, going back to sort of construction point, do you see the government actually understanding or driving innovation?
No, not at all.
Do you think there's enough sort of two-way between them and the industry?
I mean, we were asked briefly to speak to some parliamentary group. We applied for funding, we didn't get it. Nobody's coming to ask me about this from the government. And yeah, I don't know.
It's true, actually. I moan about architects not being talked to enough, but actually, I don't think everyone's talking to engineers.
Yeah. Well, I mean, I guess, you know, engineers, you know, they've got off their butts. They have a lot of the answers. And I think there's that they, you know, that they potentially have the technological know-how to solve and address a lot of these problems if they were properly involved in the process. I think they have got kind of, I mean, by and large, with a few exceptions, by and large, I think a lot of engineers have just become facilitators of construction statics rather than actually getting involved in the sort of we say the ethical, moral, economic problems of our times.
But I suppose this is the thing that to try and do something differently, you need to accept and own up to the problem, which I guess every project that lands on your desk, you're like, well, this is a problem. Carbon is a problem. We should be doing this. We should be trying to do this project differently. Is that a fair summary?
Yeah, we'll always. We'll always. Oh, so in our office, they said, you know, we were asking the. So we have an amazing team of very dedicated people who are really interested in the ethics of this stuff, and we have a whole group of people looking at social and carbon stuff. And they were saying at one point, you know, should we only work for people who want to build sustainable projects? So I'm thinking, well, that's, you know, if you've got a client who's going to build in timber, they're going to build timber with anybody. Actually, we should be working for the people who don't want to build a timber project and convincing them that it can be done, or some other low carbon solution. So we really, you know, want to take projects that would naturally be like that and try and find ways of. I mean, I think it's really important to. So we really push and advocate on projects for those things, but it's really important to be right.
Yes.
So to fully understand the problem, to understand the risks, to analyze it very carefully and thought about it, and not just kind of, you know, advocating for something you think might be kind of sexy or hip or whatever. You know, actually you really want to think the problem through from multiple directions, think about the contractor's problems, think about the client's problems and risks, find solutions that tick all those boxes, and then advocate for them quite strongly. And, you know, people very awkward about sitting in meetings with other people and really pushing for something from a moral perspective, because everyone's worried about losing their clients or annoying people or whatever.
So we need to be doing it more, and maybe I suppose that's where the industry maybe can work together a little bit more in supporting each other to try and push things into it.
Yeah, I mean, we need to. I mean, I think we end up in this kind of conflict situation where one person is pushing for something and the other person's pushing back. What we really need to do is to embrace the problems that the person who's pushing back against you has, and say, what are the issues?
Quite often costs.
Well, quite cost or
logistics.
Risk or insurance. And try and address those with a solution that answers those things. I mean, the insurance, sorry, I'm offering on the insurance thing, you know, I mean, we have projects perpetually being cancelled because of insurers not wanting to insure CLT. So they're worried about leaks, rotting,
water and fire.
Fire. I mean, that like, and just killing a lot of CLT. In Valencia, 80,000 cars were destroyed. 80,000, not to mention thousands of hectares of agricultural land, hundreds and hundreds of buildings, massive civil infrastructure, roads and tubes and everything else. The insurance claim for the Valencia flood, which is clearly attributable to global warming, is going to be much more expensive than a leaky roof rotting a bit of CLT on a few buildings, you know, or, you know, the roof might leak. You know, you can solve leaky roofs. You can solve leaky shower trays. You can solve rotting CLT.
You pay the person to come and check, maintain, and look after your buildings and care for what you have.
But the Valencia thing, that cold drop dumped all the water on one particular river on the Mediterranean and caused a total nightmare. So you think, well, we'll build a dam on that river so it never happens again. Killed 200 people.
Yeah.
You build a dam up there so that it doesn't happen again. It's not going to happen again on that river. It's going to happen on one of the other 500 rivers on the Spanish coast on the Mediterranean. So you're going to build a dam on every single one of those, as well as pay for the 80,000 cars. And like, how do you deal with? There's no way of dealing with that compared to dealing with a leaky roof.
Yeah.
You know, so it's like, oh, we can't solve the leaky roof problem, so we'll just
we become a nation of sticking plasters, I guess, rather than solving the root cause
or just,
problem.
You know, or becoming fixated with the small problem in front of us rather than the bigger, the bigger picture problem.
But we can be optimistic, or no, we're not sure.
I don't know. I think there's reasons for optimism and reasons for, I mean, I don't see, I mean, are we going to build 1.5 million homes in a low carbon way? I really doubt it.
But let's hope we can.
Let's hope we
Maybe
can.
we need to try and make it happen. I think we can leave it there. Thank you. That was really amazing. That was